The history of our planet is written in stone, or more specifically, in layers of hardened lava known as ignimbrites. These solidified blobs of molten rock are the leftovers from some of Earth's most violent ancient volcanoes, many of which were so colossal that they literally reshaped the continents. But while scientists can analyze these deposits to learn about the eruptions that created them, they also want to know where those eruptions happened. That's why archaeologists and geologists around the world are searching for the lost giants, the source calderas of some of the most destructive volcanoes in Earth's history. And their search is shedding new light on some of the planet's most dramatic events. Take, for example, the Zunino Ignimbrite, named for the Italian village it was first found near. This particular type of solidified lava is one of the youngest on record, coming from an eruption that occurred just 23,000 years ago. It unleashed over 480 cubic kilometers of ash and pumice during what would have been an apocalyptic eruption. The amount of material alone makes it the second largest volcanic eruption of the past 2 million years, only beaten out by the 700 cubic kilometer eruption that formed the Yellowstone Supervolcano. And yet the identity of the volcano that created this massive deposit remains a mystery. Scientists know that it came from somewhere in southern Italy because that's where the fine ash settled. But pinpointing its exact location has proven difficult. The problem is that on a map, the spread of the Zunino Ignimbrite looks an awful lot like a bullseye. You might think that this would make it easy to figure out the eruption's epicenter, but it turns out there are actually 7 different volcanoes in the general area whose hypothetical eruption plumes could explain this pattern. To figure out which one is the culprit, scientists have turned to computer modeling, feeding data on wind speed, direction, and volcanic explosivity into a program that simulates the spread of volcanic ash. By comparing the results to the real-world distribution of the Zunino Ignimbrite, they hope to find the best match and identify the source volcano. So far, their models suggest that the eruption was most likely caused by one of 3 volcanoes, which will hopefully narrow things down once excavations at the sites are complete. But even if the caldera itself can't be found, the eruption won't stay hidden forever. There's no shortage of evidence left behind by such a cataclysmic event. For instance, the Minoan eruption, which occurred on the island of Crete around 1600 BCE, was so powerful that it caused widespread devastation across the Mediterranean. In fact, some scholars believe that the eruption may have even contributed to the collapse of the Minoan civilization. While nobody knows exactly what year the eruption took place, scientists did discover substantial amounts of the radioactive isotope carbon-14 in tree rings from that time period. Carbon-14 dating is based on the fact that after living things die, they stop accumulating this isotope and begin decaying. So, finding elevated levels of carbon-14 in ancient tree trunks suggests that something unusual must have happened that year, namely, an enormous volcanic eruption. Of course, while carbon-14 dating can tell us when the eruption occurred, it can't tell us where. But geologists have discovered other clues. Pyroclastic flows from the eruption traveled along ancient riverbeds, leaving behind deposits of volcanic debris that are up to 24 meters thick. And since we already knew that the eruption happened sometime before 1600 BCE, archaeologists could date the riverbed sediments by identifying artifacts deposited alongside them. A bronze dagger found near the top of the flow in the western Peloponnese dated to around 1450 BCE, while another piece of pottery found at the base of the flow in central Greece dated to around 1600 BCE. Together, these pieces of evidence have helped scientists trace the path of destruction left behind by the Minoan eruption. And they even found the remains of marine organisms at higher elevations than where they live today, suggesting that whole ecosystems were literally blown away by the force of the blast. But despite all of these discoveries, scientists still aren't sure which volcano was responsible for this devastation. Several candidates have been proposed, but none fits all of the available evidence. So the search continues for the lost giant that brought an end to an era. Fortunately, not all lost giants are quite so elusive. Researchers recently identified the long-lost caldera of Australia's mega-volcano, which researchers had suspected existed beneath the southeastern part of the country for years. What gave it away was a circular low area in the otherwise flat landscape. But it wasn't until scientists collected detailed gravity readings that they could be sure. Caldera forming is a normal part of the volcanic life cycle. As pressure builds beneath the Earth's surface, magma pushes upward, eventually erupting as lava. But once the magma chamber is emptied, the overlying land has nothing to hold it up anymore and collapses inward. And that's what happened here. When scientists analyzed data collected by the Australian Gravity and Magnetic Survey, they discovered a perfectly circular gravity anomaly sitting right beneath the low area, indicating that the ground above it was both lower and denser than the surrounding areas. This was strong evidence that a magma chamber had collapsed to form a caldera, but they needed to get a closer look. So in 2019, researchers led a drilling expedition to collect samples from beneath the sediment. But the drilling process itself revealed an unexpected discovery. Before they reached bedrock, they hit water. Turns out that this part of Australia is a huge lake, twice the size of nearby Lake Victoria, and getting to the bottom of it is going to require a totally different kind of drilling technology. But when they finally reach bedrock, the team will be able to answer a host of important questions about how this mega-volcano shaped Australia's landscape and whether or not it's still active. Because here's the thing about volcanoes. Once they finish erupting, they don't just go away. Their shape and size can change over millions of years due to erosion from wind, water, and ice. So while some ancient calderas are so worn down that they look nothing like a volcano, others are so well preserved that they're still clearly visible on the landscape. Take, for example, Ngorongoro crater in Tanzania. With a diameter of 60 kilometers and a depth of 600 meters, it's the world's largest intact volcanic caldera. Or consider the enormous La Garita caldera in southern Colorado. At 50 kilometers wide and 2,000 meters deep, it's the largest known caldera in North America and the second largest in the world. But if you ask me, nothing beats Ulton, a submerged caldera located in Italy's Lake Garda. It was first described back in 1717, but nobody knew that it was a caldera. Instead, people believed that the lake had been formed by a meteorite impact. That's because the lake is perfectly round with sheer vertical walls and a flat bottom, which isn't typical of most lakes. Even today, most of the caldera is hidden beneath over 240 meters of water. But thanks to modern technology, scientists have been able to create a detailed map of its features. They discovered that it has a diameter of 18 kilometers and a maximum depth of 300 meters, making it the deepest lake in Europe. And they uncovered evidence that the area has been volcanically active for the past 2.6 million years, although no eruptions have taken place in the last 60,000 years. Perhaps one day we'll uncover more lost giants like this one, or perhaps some of those mysterious European Bronze Age cultures had a much better understanding of our world than we've given them credit for. After all, prehistoric people were known to migrate from island to island throughout the Mediterranean, and it seems unlikely that they would have missed such a monumental eruption unless they were already gone by the time it happened. So, it's entirely possible that humanity's history is filled with gaps, entire civilizations that vanished without a trace. Fortunately, scientists are working hard to fill in those gaps and shed light on the past. So if you want to stay up to date on their latest discoveries, make sure you subscribe to our channel.